Hello everyone, welcome to Tech Systems. In this video, we will talk about BACnet. After watching this video, you will learn what is BACnet and why it was developed, what are objects, services and LANs, what is BACnet architecture, and you will also learn about basics of BACnet IP and MSTP networks. BACnet is an acronym for Building Automation and Control Network. It is a data communication protocol for building automation and control networks. BACnet was developed and being maintained by American Society of Heating, Refrigeration and Air Conditioning Engineers. BACnet is an international standard with recognition from ISO. BACnet is an open protocol, so any manufacturer is free to create products based on the BACnet technology. Before discussion about BACnet protocol, let's see why BACnet was developed and what are advantages of a common open protocol. Consider a building consisting of different systems. Each system is supplied by a different manufacturer and is supporting a different proprietary protocol. For example, HVAC control here is supporting protocol A, while access control is supporting protocol B. And similarly, lighting and fire alarm systems are supporting other different protocols. As all systems are supporting different proprietary protocols, so we need different workstations for each system, which means we need more number of operators and training to manage the system. Also, these systems cannot talk to each other due to different protocols, so expensive gateways would be required if we want to integrate these systems together. Also, with the use of proprietary protocols, owners would be bound to purchase products from a single manufacturer, which means owners cannot use products from large database of the vendors. That's why we need a common open protocol so that all these devices can communicate with each other without any issues, and the owners would also have the freedom to choose from a large number of vendors. So BACnet was developed as an open protocol so that different systems can integrate with each other easily and can be controlled and monitored from a single workstation. This would also reduce required operator trainings and owner would have the benefit of choosing from a large number of vendors. Also, these systems can easily talk to each other and can be integrated if required. Let's first define what is a data communication protocol. It is a set of software and hardware rules which enable devices to talk to each other. Let's consider we have two devices which want to communicate with each other. For communication to happen between these two devices, we need two things. First is a protocol which is like a human language, and we define a protocol as a set of rules for processing and formatting of the data. Both devices shall understand the common protocol in order to communicate with each other. Apart from the protocol, we also need some physical media through which the protocol messages can be transmitted. In case of computer networks, this media can be a Cat6 cable, which we usually use for IP communications. For Wi-Fi communication, radio frequencies are used as a media to transfer the messages. So for any communication, we need two things. First is a protocol and second is a physical media. Now let's have a look at different applications of BACnet protocol inside the buildings. BACnet is used for HVAC control, fire alarm systems, lighting control, access control system, and elevators. To know about BACnet, we need to understand about objects, services, and LANs. LAN stands for a local area network which defines physical means of connecting different devices with each other in one physical location. We will look at each of these into more details. Let's see what is an object. It is a collection of information related to a particular function that can be uniquely identified and accessed over a network in a standardized way. Now let's see what does this mean. Objects can represent physical inputs, physical outputs, and software process. Physical inputs can be analog inputs or binary inputs. Physical outputs can be analog outputs or binary outputs, and software process can be a time schedule or a temperature set point inside the BACnet device. So all these are examples of BACnet objects which provide some kind of information that can be accessed over the network by the other devices. Each BACnet object is defined by a set of properties that describe its behavior and govern its operation. Let's consider an analog input object which is representing a temperature sensor value. Here are some properties related to this object which provides us very useful information about this object. First of all, we have object identifier, which is a 32-bit code that identifies the type of the object and its instance number, which together uniquely identifies the object within a device. Within a device, object identifier will be unique for all the objects. For example, here we have object identifier as analog input. Number 3, here analog input is representing the object type, and number 3 is the instance of that object. So this AI3 is a unique identification for this object. There will be no other object with the same identification. We can have another object like AI4, AI5 like this. So that's how objects are uniquely identified within a device. Then other property, here we have a object name. This is for example, here we have supplier temperature. Object type is an analog input. Then we have a present value which is representing the current value of this temperature. So mostly we are using this value to represent in our graphics and to get the information about the temperature. Then here we have a status flag to give the status about this point, is it normal or out of service. Then we have high limit and low limit. These limits can be defined in order to generate notifications and alarms. If temperature value is outside of these limits, then a notification or alarm will be generated at the workstation. Then description can be provided for that temperature, and device type can also be a property. Some properties are required properties while other properties are optional. As I shown here for this analog input point, required properties are shown and optional properties are also there. So manufacturer is free to choose either he need to implement the optional properties or not. BACnet currently defines 60 standard objects. Standard objects keeps evolving with the development and revision of the BACnet standard. I have shown some important standard objects here. To know about all the standard objects, you can visit BACnet official website. Some of the important objects are devices, analog inputs, analog outputs, analog value, binary input, binary output, multi-state input, and all these, like these are the important ones which you will see as points. Then other objects you can also go into details about them. BACnet requires one device object to be present in every device. The device object makes information about the device and its capabilities available to other devices on the network. Device properties provide information about the device. Unlike other objects, the device object's instance ID or instance number must be unique across the entire BACnet internetwork because it is used to uniquely identify the BACnet device. This point is very important for the BACnet. Two BACnet devices must not have the same object ID or the device instance ID. So BACnet device itself is an object which provides information about that device. So a BACnet device is a collection of objects which represent the functions inside a real device. That's why virtual devices can also be considered as BACnet devices as well as the physical devices. That's why your BACnet workstation also is considered as a BACnet device, although it is not supporting the hardware physical I/O points. So each BACnet device must have a device object which will give us information and about that device and its capabilities. Now let's see what are services. To understand services, consider that we have a BMS workstation and a BACnet controller. Controller contain many objects and space temperature is one of them. Now workstation wants to read the present value of the space temperature object from the controller. How workstation will read this value from the controller? This is where services comes into action. These are messages between the devices to access the data. To read temperature present value, workstation will use a read property service to request data from the controller. In response, controller will reply with that data to the workstation. BACnet follows client service model relationship for the communication between the devices. Client is the device which requests the data, while service is the device which responds to the requested data. So in this scenario, workstation is a client and the controller is a server. BACnet services can be confirmed services or unconfirmed services. Confirmed services require reply from the devices, preferably with the data. Example of confirmed services can be a read property, which we just saw earlier, while unconfirmed services don't require the reply. Examples of unconfirmed services can be time synchronization, whois and IM services. Whois and IM services are broadcast messages which are used to discover devices on the BACnet network. BACnet currently defines 38 services and classifies them into 5 categories. Let's have a look at each of them in details. First of all, we have object access services, which provides means to read, modify, and write properties and to add and delete the objects. Here are the object access services, which include many properties like read property, write property multiple. BACnet devices are not required to implement every single service. Just one service, read property, is required to be processed by all devices. Depending upon the function and complexity of the device, additional services may be implemented in a device. Alarm and event services are used to provide notifications about alarms, events, and change of value or COV notifications. Example of an alarm or event notification can be an alert notification if an AHU supplier temperature goes out of the defined temperature range. COV or change of value notifications are a useful alternative to the continuous polling of an object for some monitored value. To understand COV, consider an example of a workstation and a controller which contains space air temperature. If polling is used to read the object, workstation will continuously keep sending requests to read the temperature. If multiple devices are polling the data from the controller, it will result in large traffic and could lead to communication problems or slow response by the controller. On the other hand, if COV notification is used, controller will monitor the object itself for any changes in the value. When value changes by a specified amount defined in the controller will send notification containing the object value to all the devices who have subscribed for that object. For example, if space temperature value changes from 24 to 25, controller will send notification to the workstation who have subscribed for space temp object. So COV is a very effective method to replace the continuous polling of the objects, which result in a large number of traffic on the network. File access services in the BACnet are used to read and manipulate files in the BACnet. Remote device management services are used to configure and maintain devices and the systems. Examples can be time synchronization service, which allows devices time clock to be synchronized with the workstation time clock. Other examples can be whois and IM services, which are used to discover the devices on the BACnet network. Then we have virtual terminal services, which can be used by an operator to establish a bidirectional text-based connection with an application program executing in a remote device. For those of you who are familiar with Open System Interconnection Model or OSI model, BACnet adopted collapsed architecture consisting of 4 layers, which are application layer, network layer, data link layer, and physical layer. Application layer handles the information inside the devices in the form of objects and handles BACnet services for communication between the devices. Data is communicated at the application layer in the form of APDU or Application Protocol Data Unit. Application layer also handles actual interface with the user's application program. Network layer handles routing of messages between different networks. It includes translation of global addresses to the local addresses. Consider an example where we have two BACnet MSTP networks with network number 2000 and 3000. So any communication between devices in these networks, for example, if device 1 in network 3000 wants to communicate with device 2 in network 2000, so this communication between these two different networks would be handled by the network layer. Data link layer handles device to device communication within a single network. It organizes data into frames or packets and transmit it to the other devices within a same network. Here the communication of devices within the same network would be handled by this data link layer. Physical layer defines the physical media for connecting the devices and handles transmission of electronic signals that convey the data. Here we have the BACnet layers compared to the equivalent OSI layers. Now let's have a look at the LAN options supported by the BACnet. BACnet supports Ethernet, ARCnet, BACnet IP, LAN talk, and MSTP, Master Slave Token Protocol. BACnet IP and MSTP are most commonly used in these days buildings, so that's why we will cover only both of them. BACnet IP uses IP or Internet Protocol, which is a fundamental protocol for IT networking. IP devices are directly plugged into Ethernet switches. IT support is critical to enable BACnet IP devices to run on enterprise LAN. So what devices shall use the BACnet IP network? The devices which need high performance connections, devices that need to transmit a lot of the data shall use the BACnet IP protocol. Consider an example of a chiller plant control and monitoring. Here we need a high performance and fast communicating DDC controller. So BACnet IP would be suitable for this type of application. Now let's have a look at pros and cons of using BACnet IP. BACnet IP is a high performance network and is very fast. Switches and hubs makes it possible to have as many devices as required on the network. IT network is usually already in the place inside the buildings. IT staff already is familiar with the technology. Assigning IP addresses to the devices makes them web accessible. Now let's talk about cons of BACnet IP network. Usually BACnet devices are more expensive than other network type devices. We must rely on the IT teams and follow their rules to connect our devices on the network. We may need IT support for making changes to the device layouts or connectivity. If IT makes some changes in their network, it may affect our device connectivity. Now let's talk about BACnet MSTP. MSTP is a master slave token protocol. It uses RS-485 electrical signaling standard with twisted pair cable. It supports distances up to 1200 meters maximum without the use of repeaters. Baud rates supported are from 9.6K to 76.8K. Some devices are also supporting 115K baud rates today. What devices shall use BACnet MSTP? Small local devices that don't send a lot of data, and unitary and application specific controllers shall use BACnet MSTP networks. Controller used for control of VAV boxes are example of controller which don't need to send a lot of data. BACnet MSTP is used for these controllers. BACnet MSTP devices are wired in a daisy chain using a shielded twisted pair cable. It is very important to use correct type of cable which is compatible for use in RS-485 signaling. Use of inappropriate cable can result in communication issues on the network. End of line or termination resistor is used on the last devices to avoid signal reflections on the network. Usually 120 ohm resistor is used as end of line resistor. Logically, BACnet MSTP supports 127 master devices in a single loop, but it is recommended to not use more than 30 to 32 devices in a single network loop. Always refer to the manufacturer datasheets to know about the maximum limits of devices on a single network to avoid communication issues. Each MSTP device have a dip switch to define the MAC address of the device in the network loop. Each device in a network shall have a unique MAC address. A router is used to convert the MSTP to IP for control and monitoring from the BMS workstation. As you can see here, a BACnet MSTP to IP router is used here, which is connected to MSTP network on the one side and on to the BACnet IP network on the other side. So the communication between BACnet MSTP and the IP network is being handled by the network layer, which we discussed earlier, that the communication between two different networks will always be handled by the network layer. Now let's have a look at pros and cons of using BACnet MSTP. BACnet MSTP is most cost-effective network type. It can be implemented without the help or constraints from the IT teams. Then we have some cons also, that it has lower speed than the IP. and limited number of devices can be used in a single network. So guys, that's all for this video. If you find this video useful, please give it a thumbs up and subscribe to my channel for more videos, and also support us on Buy Me a Coffee. I will give the link in the description.